so now we are doing problem 10.3, number 13 in the review. It says, 3 different local hospitals in New York surveyed their patients. The survey asked whether the patient's physician communicated efficiently. The results given as joint relative frequencies are shown in the two-way table. Okay. What is the probability that a randomly selected patient located in Saratoga was satisfied with the communication of the physician? All right. So this gets back to that conditional probability stuff that we've mentioned, right? The condition in this case is that the patient is located in Saratoga, okay? That's going to be the condition. So right off the bat, we're looking at this guy. We're looking at the Saratoga. We're just going to hone in on the Saratoga column, okay? We want to know the probability, given that they live in Saratoga, were they satisfied? Okay, so this is going to look like the probability that they were satisfied given we're at Saratoga. Okay. Alright, yeah, you can see that. So, how are we going to find this? Well, here's what we do. You look at the probability, yes, they were satisfied. That's 0.288, okay? But it's given that they're from Saratoga, right? So to get the total number, the total percentage of folks from Saratoga, we add these two values up, and that serves as our denominator. So we'd have 0.228 plus 0.077. And that should give us our value for this one, okay? Be sure you understand how to do this. Part B, what is the probability that a randomly selected patient who was not satisfied with the physician's communication is located in Glens Falls? So this one's a little different. Here, the assumed piece of information, the given piece, the condition, is that they were not satisfied with the physician's communication. So if I set this one up, the given is not satisfied. Okay? But now we're looking at the probability that given you are not satisfied, were you in Glens Falls? Glens Falls, okay? So we're going to look back at this table, and now we're talking about the probability that you were not satisfied, right? That's the condition, I'm sorry. The condition that you were not satisfied, and the probability that you're in Glens Falls, right? Well, if we go to Glens Falls and know, that's just 0.042. Okay? And that's going to be our number in the numerator. But our given is that they weren't satisfied. So in this condition, in this example, we're going to hone in on this row. All right? This row down here. So to get the value for our denominator, we have to add up all 3 of these values, okay? And that's because the condition was that they're not satisfied, and then we're curious about the probability that we're in Glens Falls. So we have to put this value for Glens Falls over the sum of everyone who was not satisfied. So we get 0.042 plus 0.077 plus 0.131. All right, and then if you do this out, you should get the correct answer. All right, let's do it for C. This is the last one of the whole set. Good for you, you made it. Determine whether being satisfied with the communication of the physician and living in Saratoga are independent events. Oh, remember we talked about this one in class. I'm glad we covered it. Unless you were first hour, I don't think we did, in which case, my bad. My apologies, first hour, we covered it and all the others. All right, but that's okay, you're here now. So, to determine whether they're independent events, what we have to do is we have to consider the probability that you were satisfied in general, okay? We're going to consider that probability, and we're going to look at the probability that you were satisfied given that you live in Saratoga. Okay? And now, if these two values are approximately the same, then they're independent. It doesn't matter whether or not you live in Saratoga, you're still going to be equally, you have the same probability of being satisfied. But if the service in Saratoga is particularly bad, we'll probably see a difference between the general probability of being satisfied versus that just in Saratoga. And if that difference is present, if these two aren't about the same, and they don't have to be perfectly the same, but maybe within 1 or 2%, if they're not the same, then the events are probably dependent. There's probably some reason people aren't satisfied, given that they live in Saratoga. So we just have to figure each one. All right, so let's do this. We have to look at the probability that they were satisfied. Well, the probability that you were satisfied is just all three of these satisfieds added up, okay? So that's just going to be, let's see, everyone who was satisfied was 0.123 plus 0.288 plus 0.338. I just added all these numbers up, right? That's where that came from. We add those up, and that gives us the total probability that we were satisfied, all right? I'll let you do that. But now we have to look at the probability that you were satisfied given that you were in Saratoga. Well, luckily you already calculated that in part A, right? So you already have this. I'm going to write 0.288. And if you're confused about how we did that, just restart the video, go through part A again. Plus 0.077. Okay, so we have two probabilities. If these two equal one another, if this one probability is about the same as this probability, then we can say that the events are independent. Then it doesn't matter if you're it doesn't matter where you live. It doesn't matter that you live in Saratoga. You're still just as likely to be satisfied with the service, okay? If these two are not about the same value, well, then these would be dependent events. And I'll let you figure that out on your own, okay? All right, I hope this helped. If you use these videos and you liked them and you'd like to see it again, let me know. And if no one says anything, I'll assume that you just never heard these instructions and that the videos were kind of a waste of my time, and I won't do it again. So if you like these, let me know. Otherwise, don't say anything and we won't see them again. All right, have a great rest of the time studying for the quiz.